right, now we have Russell.
Hey, everybody. Hi, I'm Russell Spitzer, and unlike the previous two talks, I'm mostly going to talk about philosophy and some of the technology that we've already got implemented inside of the Iceberg project and where I think it's going. So without further ado, we're going to talk about transactions today. And if you aren't familiar with this concept, we're basically saying we have a table in one state and we're trying to get that table to another state, and there's some set of changes that we'd like to apply. And ideally, this all happens in a nice atomic way. And I wrote a whole talk about this for Iceberg Summit tomorrow. And then I realized that it was way over time. So I cut off the end of it and I asked very politely if I could give it at this meetup. So we're going to hear the end of my talk from tomorrow today. Yes, so we're going to talk about three things, basically. First, we're going to talk about how catalogs first were implemented inside of the Iceberg project and what that meant in terms of limitations and the reasons that we then moved on to REST catalogs, which is the current focus of the project. And of course, then we'll talk about where we think things are going, or more specifically, where I think things are going and hope they will continue to go. But I'm sure we'll have disagreements as we move forward with the community. So let's start. If you don't know me, that's me. I'm Russell Spitzer. I live in New Orleans. This is me with a mild level of glitter during Mardi Gras. Please come to New Orleans and celebrate with us. I'm on the Apache Iceberg PMC. I'm also on the Apache Polaris Incubating PPMC, and I've contributed to many Iceberg, or many Apache projects, so I'm very familiar with open source. Now, we're going to start by talking about where catalogs kind of began in the Iceberg project. And one thing that I like to do when we talk about Iceberg is bring it back to the specification. So if you aren't familiar, Iceberg is built on a specification, which is basically a set of terms on how we've decided Iceberg terms will interact with the broader universe. And in case you didn't know, we actually have definitions within the specification on how you transition from one state of the table to another. And we have two specific examples of it inside of the specification, one for file system tables, one for metastore tables. Now, I've kind of paraphrased the text here to make it fit on this slide, but to break it down for you, in file system tables, we decide what the latest state of a table is by just looking for a table with the very highest version number next to its metadata.json. Once we've found that, we can make a new state of the table based off of that. And then we rename our new metadata that we've created to v+1 metadata.json. I'll talk a little bit later about how that actually works transactionally. But one key thing to know about file system tables is they are deprecated. Please do not use them. We are moving away from this in the future. It does sound really great because you can basically have a table without any kind of catalog interactions, but it ends up making it very difficult for the project to move forward with more complicated features in the future. So we are actively trying to get people to stop using this. The other classification of catalogs is metastore-based tables. Now here, you basically have some kind of third-party entity that's in charge of keeping the state for your table. And specifically, as we write in the specification, when you want to make a change to that, you go to this system, and we don't really describe how you do that, but you go to this system, you ask it for whatever the current state of the table is, it gives you that. You then create a new metadata.json again, based off of that current state. And then you ask the metastore to atomically replace the previous state with this new state in a transactional way. So let's walk through both of these methods just to show basically how that's built out. So starting with file tables, I might have v1 metadata.json. So if that's the current state of my table, I did an ls on the directory where all the metadata.jsons are. This is the only one. It's the highest value. I know that's what the table is right now. So the next thing I do, according to the spec, is I write a new file with just a random title. Now, this is really important because in a file system-based table, the actual identifier in the file name tells me what the state of the table is. So if I named this v2 right now, I might have another concurrent writer that also tries to write v2. And now I have two people both trying to write the same file, and I've basically broken all of my transaction guarantees. So we start out by writing it with some kind of random string. We then make a very important action, which is we do a rename of this random string into v2 JSON. Now, this is where the actual transaction happens. And this is why we write that you need to have an atomic rename operation. And what that means is that if I rename random into v2 JSON, there better not be a success if that file already exists. I need to atomically be sure that the file system will not allow multiple simultaneous renames of various other random.jsons to v2 while I'm trying to do it. Now, famously, back when the Iceberg project was a lot younger, S3 was not able to do this, which meant that if you tried to use a file-based table in S3, it would instantly corrupt itself as soon as you had concurrent writers. Now, more recently, S3 actually does now have an atomic rename here, but we've moved past kind of the capabilities in this model, and we're trying to get to a better place. So anyway, once I've done my rename, now if I do a list in the directory, I see that the highest version is v2 and it's not v1, which means this is the current state of the table. My transaction has succeeded. For Metastore tables, we involve what my daughter told me was the purple pancakes. So the purple pancakes here represent some kind of external data source. This could be Hive, this could be a REST catalog, it could be all sorts of different things. But basically the idea is, again, I talk to this external service and it gives me a path. And that path tells me what is the current state of the table. Now this time, when I'm working with this, sorry, I had a little edit on the slide, it's missing, but we actually call it M1 and then we put a little bit of garbage after that, just some random bits there. Because in this case, I can have multiple people all writing M2 at the same time because I'm not listing the directory to figure out which is the last one, I'm actually looking at this catalog. So as long as they're all writing unique file names with M2 in the front or something like that, I can make this transition. Now, here, the safety of my transaction is based on my guarantees that this stack of purple pancakes gives us. We need to make sure that it has an atomic check and swap operation because basically our commit can only succeed if we know that the initial state is M1. So basically, we'll do a check, we'll flop, and now the state is at M2, and we've successfully committed our transaction. So, we have these two definitions. What about code? If you look inside the Apache Iceberg repository, you'll see that we actually have implementations for lots and lots and lots of different catalogs. On the file system side, we have this Hadoop plugin, which basically lets you do that file system table approach I listed. And then for Metastore catalogs, we actually have tons of packages in the Iceberg repository. We have one for Hive, we have one for JDBC, we have one for Glue, one for Dynamo, ECS, Nessie, Snowflake. And if you look at the new Amazon S3 tables, they similarly use this mechanism down on the column on the right. Now, for those of us who are running Iceberg at a large scale, this is okay. But what it means is that each of those different implementations basically has to implement two specific classes inside of the Iceberg repository. One is the catalog class. This is the catalog API, which tells how to make new tables in whatever your purple pancake has to be, how to drop them, how to list them, all that sort of stuff. And then slightly more dangerously, something called table operations. Table operations tells us how to actually get the table state and do a new commit. And this, to me, is where all the danger happens. So what we end up doing here is then for each of these implementations, we have two new classes. So for JDBC, we have JDBC catalog, JDBC table operations. For Hive, we have Hive catalog and Hive table operations. Nessie catalog, Nessie table operations, and then so forth. I didn't write the names in, I just wrote other over and over again, but you get the point. We basically are ending up maintaining tons of different things where all basically have the same logic underneath. But that's not it, because we also have a versioning problem, which means that every client who's choosing to use these plugins might be using a different version based on which Iceberg library they happen to be using. So I might have some clients that are using Iceberg 1.3, some that are using Iceberg 1.4, and some that are using 1.5, all talking to the same catalog. So this is really dangerous because if I have a bug in Iceberg 1.3, and I would really like people to stop using Iceberg 1.3, I cannot do that because my catalog down here has no way of knowing that Iceberg 1.3 is doing this operation because all the logic to deal with this catalog is up inside that Hive table operations bubble and not down here inside of Hive. So this is pretty scary. Now, why do I say it's so scary? Let's walk through exactly how Hive actually does this. So inside of Hive table operations, we start out by getting what we assume is going to be v.1, v1, v plus one metadata. Well, we've got our new metadata. We need to do an atomic swap because, like I said before, we have to make sure that when we're switching this, we are switching whatever is the current version for v plus one. So the first thing we do is we take a lock. I know Peter isn't here. He made an alternate way to do this, but this is the old way, so I'm going to talk about it. We obtain a lock. This is classically really difficult. We then get the current metadata. We check whether it's the same as the one we thought was V. And if it isn't, though, or if it is, we're able to do an alter table request. We actually do a literal alter table on an HMS table entry and change a table property, and that's the new state of the table. But if we fail, we now have to release our lock and go back and generate a new V1 metadata for the table based on the new current metadata. So this leads to lots and lots and lots of different problems. We have problems with validation. We have problems with different clients. Some are broken, some are not. All kinds of bad stuff happens, not to mention the fact that our catalog implementation may not understand some of the conventions we're using. So for example, in Hive, you almost certainly, if you've been using a Hive metastore, have to disable schema checks and disable the ability for it to actually check if file locations exist, because your metastore doesn't actually need to touch the file system in this example. So we have a lot of problems. This is really difficult to manage if you're running a large system with a lot of Iceberg tables, which leads us to developing the REST catalog. So the REST catalog aims to fix a lot of this. So if you remember in our original example, we basically switched from one file to another file with our purple pancake, but the REST instead gives us this new kind of concept of sending changes instead to another complete separate service that knows how to handle that set of changes and produce the metadata that we want. Now, this gets done through a set of updates and requirements. And you'll notice that we can now more descriptively actually tell the service what we're trying to change about a table. In the previous example, we're basically just saying this is the new metadata.json, take it or leave it based on whatever the old state was. And if we fail, we have to rewrite this whole thing. In this case, if we're doing different things from different clients, those things don't necessarily have to conflict because we can actually tell what we're trying to do in the commit rather than just swapping a file. And along with that, we can set different requirements. So different clients can say, I only want this to succeed if certain things occur. So we basically have a much broader way of describing how clients interact with the server. And the really cool thing about this is it quickly opens up the ability to do multiple table transactions, because now our API lets us just stack a bunch of these updates for different tables inside of the same payload. And we can have a catalog actually say, I'm getting all of these different updates, please commit them all at the same time to multiple tables. So really exciting. And we, of course, have eliminated our problem of having multiple versions all trying to interact with the same thing, because now we have this nice external service which can tell which level of client is talking to it and reject requests that it doesn't want to. So we have a lot more control in these larger Iceberg environments. Now, things are a lot better still. We don't really have to worry about upgrades. If we want to upgrade, we upgrade our REST catalog. We don't have to worry about all of our clients. It's still not great because we still have a lot of data generation on the client side, and our validations are still pretty coarse. So that kind of leads to where I see the project going next, and I'm going to push in this direction. The REST API could handle much finer grained validation requirements and finer grained, basically validation checks. So we can basically have our clients be more expressive in telling the server what exactly they're trying to do. And that would allow for more complicated logic on the server side for deconflicting these and producing next states of the table. Of course, we're also excited that there's a lot of new implementations of the REST spec coming out. I wanted to do a quick pitch for Apache Polaris, which is one of the projects that I'm working on. So the future really looks like we're investing a lot of time and effort into these. So if you aren't on a REST catalog yet, I would start checking out the various implementations that are available. And with my few remaining seconds, I'd like to encourage everyone in this room to please become a member of the Apache Iceberg community. You've already done the big step. You've come to an actual Iceberg meetup, and I assume everyone here is also going to the summit tomorrow. So, you're already big step, but what I want to let you all know is that everyone here, regardless of whether you know or not, you are a valued member of the Iceberg community, and we want to hear from you. Everyone who does work committing and doing PMC work wants to hear your voice, so please reach out to us on the dev list, go into our Slack. There's an Apache Iceberg community Slack. We have community events. Please attend as many as you can. And of course, if you just have bugs, issues, new features, go on the GitHub and start new issues. We're always always happy to see them. It really helps us understand how the project is working. And of course, please check out the rest of my talk tomorrow, which I will talk all about isolation and validations and how they actually work inside of the Spark system. And thank you so much for listening to my talk. Again, I'm Russell Spitzer. I'm currently at Snowflake, and we are also hiring. And I didn't put that on the slide, but yes.
We're out of time, but maybe we can fit in just one question from the audience.
Thanks, Russell. This was a good talk. A question on metadata services, because you have to run some service to manage the catalogs. My question is mainly around how do users manage these and scale out these services so that, like, currently we use Iceberg as a library and scales out pretty well, like with storage. Now we have to scale a service which also scales out with storage. So what is the recommendation or thought process around that?
Yeah, I mean, this is a challenging question. And I think the key thing to do is look at your implementation of your REST catalog and make sure you're using one that has a distributed persistence layer behind it, because that's probably where all of your scaling things are going to come into play. Because at its core, we're still doing really an atomic swap somewhere. And if you have a system that can do distributed atomic swaps, at scale, you're good. At least that's my opinion, but you're in a room here with authors of many catalogs, including some of the folks from Tabular here, who I'm sure would love to tell you about their decisions in doing that. From the Polaris standpoint, we're making sure that our system is compatible with, Mongo and NoSQL, as well as replicated SQL services and things like that. But I think that's the main thing. We'll probably see this whole space mature a lot more as time goes on, and I'll probably have a better answer for you then. But I think this is the future, so keep an eye on the space.
Thank you. Thank you.
All right. Thank you, Russell.
All right. Thanks, everyone.
All right. Now we have Serhi. Thank you.